My name is Eric Zietlow. I am the Director of Developer Relations at the Akash Network. What we do is essentially the same thing that like AWS Web Services does on the compute side, but we do it in a decentralized way, and we'll dig into that a little bit here. My background is largely in solutions architecture, software development, and networking. I've pretty much spent the majority of my career working with distributed systems and complex compute. Something I actually have a passion for. I'm a little weird in that I came from that world into the crypto space rather recently. I've been about 6 months in the actual token space, but doing a lot of what I used to do in Web 2, taking it to Web 3, and hopefully make the world a better place as a result. So we're going to talk about a user today, and this is could be anyone, but this user has a problem. They want to stand up a website or a web app. They want to actually do something that is, online. Everything online runs on servers. This user needs access to those servers, and this user also doesn't have them sitting in their bedroom or basement or garage. They need to go to a service. Now, this is a common problem actually in the crypto space because everything in crypto runs on computers. Does anyone know what percentage of Ethereum nodes are on AWS right now? Anyone? It's about 80%. That's a scary number, because if you take a look at Alibaba and what happened last year with Chinese legislation basically deplatforming every crypto project from Alibaba, anything similar to that happens over here, Ethereum's going to be in trouble. A lot of other networks are going to be in trouble too, because Ethereum's not unique in that regard. So our user here, let's say they want to actually stand up an RPC node. Chain doesn't matter, whatever chain you want, but they want to stand up an RPC node. So what would they have to do? Well, typically, they would have to go to one of the big providers, and they would have to say, I need compute, I need to rent some resources from you in the cloud. That provider says, great, I'm happy to take all your money, swipe your credit card here, and we're off to the races. Now, you'll notice the names have been changed there to protect the innocent, or guilty in this case, but essentially there is a very small playing field when it comes to who's actually providing resources that we are utilizing in the crypto space. So it's basically 4 major players, and if you're not working with one of them, your quality of service starts to degrade really fast, and there's a whole lot of other kind of nuances that start to appear. All right, so the concept of a provider, I'm going to use this term a lot. A provider is just someone who is providing computational resources to other people. Right? So Amazon is a provider. If I were standing up a server and selling you a little bit of power on my server to run your web page, I would be a provider. Anyone can be a provider as long as they are providing compute to someone else. So in the Akash network, we took the concept of, okay, well, look at the hotel industry. What was the last major disruptor in the hotel industry? Anyone know? Just shout out. Airbnb. Exactly. Why was that? Well, they essentially took all of these people who had these resources, extra rooms, extra houses, extra whatever, and said, hey, now you can actually turn that into an earning asset. You can actually take that and turn it into something that's now active for you instead of just a static thing that you're having to maintain. We're doing the exact same thing with server compute. So we're creating a many-to-many relationship between providers and users for compute. Now this is not Filecoin, this is not SIA, this is not Skynet, any of the storage stuff. They do storage, we work with them. We do the compute. You put those two things together, suddenly we can start throwing rocks at Amazon pretty hard, which is, in my opinion, very, very cool. All right, so how do we actually achieve this? How do we make this safe? Because, right, if you have a computer and I want to run something on your computer, how do I trust that you're actually going to provide me those goods and services, that you are going to not be malicious? You could be a black hat for all I know, and you're here to mine data, right? So we need to actually start to create trust in an inherently untrustworthy world of the internet. So that's where blockchain comes in, because blockchain allows us to do a lot of really cool things around public auditing, around relationship management, and around payment assurance. And we'll dig into that here. So before we get into that, though, we have to take a look at container hosting versus virtual machines. So traditionally, if you went back 10 years and you got a cloud machine, it would have been a virtual machine. It's basically a computer that is not real. It's actually a program that lives on another computer but behaves exactly as a computer would. So when you'd go to Amazon or Google and say, I need a server that has these specs, they're not pulling a server off of a truck and putting it in a rack and plugging it in. They're just spinning up a virtual machine, handing you the credentials, and voila. You have a computer. You don't know any different. They don't care. They take your money. You're happy as long as it stays online. Well, there's a couple problems when it comes to pricing and actual functionality around these. First one is you pay for the overhead that that virtual machine actually has. So the operating system that everything you're doing needs to run, you actually have to pay to have that operating system on your VM. So that's number one. Number two is generally these are kind of predefined boxes. So if you have a workload that's very obscure, for example, maybe something that needs a ton of RAM but not many CPU cores, you're kind of locked into what their offerings are. And typically, that would mean you'd have to get a really, really big box with tons and tons of cores, even though all you wanted was the RAM, right? So you actually end up paying for a lot of resources you aren't necessarily using. And the more edge casey we get, which this is Web3, we've got some pretty big edge cases out there. The more edge casey you get, the worse that problem is. And so some of these infrastructure problems become very, very, very expensive very quickly. With containers, we're basically changing the approach. Now, containers are not something we have invented at Akash. If anyone's heard of Docker, Kubernetes, all of these have been around for a long time. They all deal with different parts of the container ecosystem. The CNCF, or Cloud Native Computing Foundation, actually does a really good survey every year where they ask people, basically, how are you running your production workloads? That website, when people go to it, what is it running on? Back in 2016, it was about, I believe, 70% of the workloads in production from everyone they surveyed were running in containers. Since then, that number has spiked to about 85% and is going up. Basically, if you're not running in a container today, you're trying to get there. So what we did is we sat down and said, well, why would we make a virtual machine hosting, kind of recreate the traditional Web 2 when everyone's moving to this cloud, what they call it cloud native, it's kind of a buzzword. Basically, it just means a very portable, extendable way of doing things. Why won't we just build it that way? So what we are, if you want to think of like a Web 2 service that's roughly equivalent, would be like EKS or Google Container Service. That's basically where we would fit into the stack. All right. Containers are always built using generally, declarative files. And these files essentially are recipes. If I were to bake a cake and I took a recipe, I could follow the instructions, put the right ingredients in, and at the end of the day, if I put the right amount of temperature, the right amount of time, the right ingredients, I should end up with a repeatable result. That's the same exact concept behind a container. In Akash, we use something called an SDL file. And it's the exact same concept of if I have an SDL file, and I can hand that to someone, and they can follow the instructions in that SDL file, I will always end up with an exactly identical image of the container I want. So it's actually really useful, and it's really cool here. We'll walk through one if we have the time here. OK, so just understand the SDL file turns into a container. If we've got that, we can all be done here, and I can go home. No, I'm just kidding. So it is kind of the core piece of this whole thing. All right, so a user, they've taken the time, they put their SDL file together, and it has all the parameters of how much RAM, how much CPU, all those things are laid out there, the container image they're using, it's all defined, but they now need to actually get that on have someone host that. Someone has to bake the cake, so to speak. So what do? Well, they go to blockchain. And they basically post this out on the chain as a request for bids. And what happens is providers on our network, and remember, these providers could be anyone from like Amazon could provide our network. They never would. They hate us. We're obviously threatening their business. But they could provide our network. Could be someone, I know a guy out in France who has like a bunch of old Dell Blade servers. He stood up and he's a provider. Could be anyone. So they're all watching the blockchain, and when a request comes through that they can fulfill, they get to put a bid on that request. Now this is the other really cool part, because if you want certain things, like you care maybe about GDPR compliance, or you have HIPAA compliance, right now we don't have any HIPAA compliant providers, just full disclosure, but if those things were concerns to you, you might be willing to pay a little more for those things, or maybe you'd be willing to work with a cheaper provider who isn't offering those things. So it's actually creating a free marketplace where people can transact, not just as big corporations with this kind of corner on the market. It actually gives the freedom back to us as the users. So Okay, so the bids hit the chain. The user actually manually gets to select the bid they want. It's not programmatic. You actually click the one, you can look at the attributes of the provider, you can tell who you're working with, and you can select the bid you need. Then the user is going to send a lease, which is essentially the, yes, I accept your bid. We now have a relationship. We have a working business relationship. I'm going to transact tokens with you in exchange for your compute. And they send an escrow. That escrow is really, really tiny. It's 5 tokens. What that escrow actually does is ensures that people get paid and no one can run away with the money. So payment happens every single block for that last block's compute. The worst case, if someone were to like cancel a lease and try to run with the money, is they'd get 6 seconds worth of burn time. That's nothing, right? That's like fractions of a cent. So there's no incentive to actually behave badly here because all of the payment transfers through this escrow to get from point A to point B. If I, as the user, were to cancel my lease early because maybe I just needed something up for a week and maybe I had 6 months worth of burn time in that escrow account, I would get my funds back. So it's a very equitable and trustworthy way to actually handle this, and it's all on blockchain. So it's actually all auditable, it's queryable, it's a really, really cool thing. All right, so once that relationship has been established and that lease is taken out, now as the user, I would send my SDL file to that provider. If you remember, I said SDL file is essentially like a recipe for a cake. Once that provider has the SDL file, they can quite literally bake it into the container. And now my website or my miner or my RPC node or whatever it was I was going to go spin up is now running. I'm returned endpoints. I'm returned all the things I would need to actually manage it. And I am now running in a decentralized cloud. The cool thing about this, too, is since we're using a repeatable recipe, I can work with multiple providers and like start putting load balancers in front. So people always ask me, like, how do you handle durability on the Akash network? Well, take out 2 leases on different providers, throw a load balancer in front, now they both have to go down. Or maybe I could do it on like, I don't know, 10 or 15 or like whatever level of durability I need to achieve, I can do as long as there are more providers. Okay, so tons and tons of providers exist out there. I need to know who I'm working with is honest, right? So what do I do? Well, that's where these things called assigned attributes come in. And this is kind of in some ways like Airbnb, how you can give someone a rating and a review, except it's all stored on chain, so it's all publicly queryable, and it's all based off of addresses. So someone can tell that such and such address took out a lease at this time, they terminated a lease at this time. Oh, and then they assigned a bunch of these attributes to the provider of like unstable, or maybe it was super great experience or something like that, or trusted or whatever. The problem is those are just user reviews. I could rate myself 100 out of 100 because I like myself. It doesn't make me any more honest or good or providing what you want. How do we actually accomplish that? Well, that's actually done through a bunch of community members. Now, currently, this is a brand new thing that the community took on as their own initiative. A company called Akash Audit was actually formed. It's a former DoD pen tester. He actually used to go around to different DoD sites and basically perform network analysis. He now is working with a bunch of the providers to validate that they're actually providing what they say they're providing. He's doing some tamper detection on container stuff, a whole lot of different levels of security with these providers. And when he does that with them, he signs them with his address, which he's published publicly, and gives them attributes. So now we can actually trust, as long as we can trust his process, which he's published open source, every single piece of it. Whoa, sorry about that. Every single piece of it, you could go and download his tooling right now, start a clone of his company with everything he's provided. So very, very auditable. The auditor is auditable, and we're encouraging more and more people to get in this space to help decentralize that auditing process. If we can get 10 or 15 auditors, suddenly now we have a pretty good decentralization for this type of a model. All right. So when that actual bidding process happens, if I filter in my SDL file off of, I'm searching for this person's signature and these specific attributes, only the people who can satisfy that, the providers that can satisfy those conditions, will even be allowed to bid. So I don't have to sit there and like sift through and double check. They don't even get to bid if they can't satisfy those requirements. So end of the day, this is my pencil scribble drawing of a tiny little slice of the Akash network, but basically, this is truly a many-to-many relationships. One provider can work with many users, and one user can work with many providers. And through that, we can achieve high durability, just the performance people are looking for. They don't have to pay for other things than what they're actually using. Now, if I have, I think, about 2 minutes here, I'm going to take and I am going to actually run a quick deployment. Can you all see that okay? Thumbs up? OK, good, cool. So what I've got here, this is a community tool. So Akash is truly an open source network. Most of the tooling, most of the different pieces of it come straight from the community. This was two guys out in Montreal who basically quit their fiat jobs to develop full-time on the Akash network. They built probably one of the best deploy tools I've actually seen. It's not quite like Heroku, but it's about as easy as Heroku, if you're familiar with that. So we're going to go ahead and we're going to create a deployment. Now it's going to check that I have wallet balance, which I do up there. There is a built-in wallet to this tool, so I could send, receive tokens, do whatever I got to do. It's also going to check I have a valid certificate, which is something I did beforehand, so we didn't have to sit here and wait for it. But essentially, that just validates that, yes, I am who I say I am. This is associated with my address. I can make changes to my deployments, yada, yada, yada. I'm not screwing with anyone else's stuff. OK, so once we've done that, we're now going to go ahead and we're going to select a template. Now, if I made my own SDL file, or I pulled one from someone else, I'd just hit empty there and I'd copy paste it into the next window. But for the sake of time here, I'm just going to choose Tetris and go ahead and continue. Now, you remember I was talking about these SDL files. This is an SDL file. What we have here is I am pulling literally from Docker Hub a Tetris image, so a Tetris game. I am setting my resources. So you'll notice here, this is not a typo. 0.1 CPU units. I am literally renting a tenth of a CPU unit because I don't need a whole CPU to run Tetris. So I'm saving money. That's one of the other kind of like cool things about container hosting. OK, I am filtering by a specific set of providers. They have to have been signed by this address in order for me to trust them. And then here is the max amount I am willing to pay per block. UAKT is a millionth of an AKT token. I'm willing to pay up to 1,000 UAKT per block, which is like 6.582 seconds, I think. I'll pay that much for compute. Now, that would be an absurdly expensive deployment. I'm really only going to pay like 1 or 2 UAKT, but just for the sake of demo here, making sure I'm getting everything returned. OK, lastly, I can actually scale straight from here. If I want multiple deployments, like I wanted 2 or 3 of these containers, I could change this number where it says count, and I'm sorry, Grammarly is in the way, where it says count. I could change that number and increase it and deploy multiple containers in one go. So I'm going to go ahead and I'm going to just say demo. This is just for my own purposes, so I can keep track of the container. Now, you remember I was talking about the escrow? That's this step right here. So I'm going to go ahead and I'm going to deposit 5 AKT. And I'm going to approve the transaction. This is literally that step where I'm taking that SDL file, posting it to chain, so there's a little bit of gas. Now, this isn't like Ethereum gas. This is Cosmos. Gas is like fractions of a penny. So I can do operations all day. I don't think I've ever paid more than like a cent for gas ever on Cosmos. So let's see here. We have a whole bunch of different providers. And I can go down and I can drill into any of these. I can see a lot of attributes that people have signed to them. I can also see what resources they have available because those things are published. So this one has 80 virtual CPUs, 8.7 gig of memory. I'm going to guess this is one that was actually set up for a miner. We have a lot of people that provide resources to miners on our network. It's a very popular use case. I'm going to go ahead and click this one. You'll notice it was 1 UAKT per block. I'm going to accept their bid, which is now doing the transaction where I'm setting up that lease, I'm setting the escrow, doing it, and in just a moment here, we should see this container spin up. Now, if I've done this all right, which in this tool it's really hard to mess anything up unless I had like a trashy SDL file that I had to clean up, we should be playing Tetris in just a minute, and I'm going to go ahead and mute it because it's got the music, and I don't want to like deafen everyone in the room. So, all right, here we go. It is spinning up. As soon as this part right here stops spinning, I'm going to go ahead, click on the URL that's provided there, and we will be playing Tetris. And so keep in mind as well that this doesn't have to be Tetris. This could be anything. This could be, whoops, OK. That's lovely. Let me go ahead and we're going to do it. There we go. All right. So yeah, I'm playing Tetris on the Akash network. That took me 1.5 minutes to spin up, maybe 2 minutes, something like that. That could have been anything. That could have been a database. That could have been a web app. That could have been a whole microservices architecture. You can set up multiple containers in a single SDL and deploy an entire microservices architecture like one shot. It's really, 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 really functional. and it works. This is mainnet. This is live. This isn't a like proof of concept demo. This is actually out there right now, and you can go get AKT, and you can transact, and you can do it. So I think that's my time. Yeah, and if you have any questions, come on, talk to us. We'd love to connect.